Hello, today we are going to unlock the TIA portal timers and see the slight difference between those of the SIMATIC STEP 7. In fact, there are two main categories of timers in PLC programming. The on-delay timers generate a time delay to activate the output. On the other hand, in the off-delay, the output turns off after a preset time. The timer's parameters include the input, the signal that starts up the timer. The PT stands for preset time. It is in here we enter the timer time value. The output turns on or off, depends on the type of the timer, when the preset time is up. ET stands for elapsed time. The timer's memory address shows up on top of the timer. The main feature which sets TIA portal timers from those of SIMATIC STEP 7 is the TIAs are supplied with DBs, data blocks. This new feature makes programming more efficient in terms of memory allocation, logic code organization, thus time saving. The SIMATIC timer is still available in TIA portal. Another crucial characteristic that distinguishes PLC programming timers is the nature of signal that activates them, a pulse or an extended signal. Well, let's go back in TIA portal and see how they work. We expand the timer operations. We've got two generations of timers. The ones in blue are integrated with the advent of TIA software, meanwhile the SIMATIC timers are the legacy of the previous versions of SIMATIC STEP 7. They actually work the same way except with the recent ones are supplied with data blocks. We explore this in detail in future videos with practical examples. Now, we can explore the information system of an instruction by heaving over and clicking on the little arrow below. Let's start with the TP timer. Here is the timer's diagram. Let's try find out how the timer works through this diagram. When the input is active, the timing starts and the output is active simultaneously and it turns off when the time is up. The timer is reset when the input is deactivated. To restart the timer again we need to reactivate the input. However, as it's shown here, even if the signal at the input deactivates, this does not interrupt the timer, that is to say the timer just need a pulse to run and the output turns off when the preset time is up. In any way we can understand this better with the simulation. We basically took this as an example to show how to read a diagram. We can therefore make a basic program to see how the different timers work. From the basic instruction toolbox, we drag the timers and put each on its own network. We start by the TP. Unlike the old Step 7 timers, the new generation are supplied with data blocks. We click on OK to add the timer. As you can see here on the left, the timer's DB is added in the system block and it's in here the different data blocks we use are added while programming. Timers are just one instruction among others like counters using DBs. Data blocks also can stand by their own. We will see this in detail in dedicated lessons. Perfect, we carry out with the rest of the timers. As we saw at the beginning of the lesson, there are three main parameters in the timer: the input, output and PT. We use an open contact and a coil for the input and output respectively, then we assign each its address. We repeat the operation with the remaining timers. Well, we are done with the inputs and outputs. Now before we can run the program, it remains for us to assign the time period to the timers. Here, in the PT, we enter the time. It's worth mentioning to choose the right scale of time. For example, let's say we need a programmed time period of 5 seconds. We just need to type the time in numbers followed by the time unit, which is in our case the seconds. Once the timer's parameters are completed, we can now move to the simulation. Today's lesson will provide us with a broad idea about the timers. However, we are going to discover the right use of timers as we advance in the course with real-world applications. We launch PLC Sim and start simulating the timers one by one. We used the byte number 1 for the addresses. Therefore in here, we modify the byte number for both the input and output, then we put the ones we used for this example. By clicking on the first input, the timing starts and the timer's output turns on and stays active until the preset time, PT, is up. Now we click on the input and release. The timer works the same as when the input was kept pressed, a newly integrated features in the Siemens software. Good. We move now to the off delay timer and see how it works. We click now as usual on the input to start the timer. As we can see here, the output is active but the timing not running. However, when we click and release, the timing starts and the output deactivates just when the preset time is over. As we can see, unlike the TP timer, this one requires only a pulse to run. So, it's noteworthy that it can be very useful in applications that require to start the timer with a negative edge. We keep simulating and move to the TON timer, the on-delay timer. Unlike the previous ones, here the output is active after the timing is done. We click on the input and keep it, the timing starts and the output turns on when the preset time is up. Now, we click and release. As we can see, the timer does not work at all. The TON timer requires an extended signal to work. Hopefully, you got the whole thing about timers. By the way, the lesson aims at providing a broad idea about timers. To have a full grasp of them, we need to put them in practical examples. Before we move to the next timer, it's worth pointing out that these timers are reset from the input signal. That's in case it is a pulse timer, all we need is generating another pulse to reactivate the timer. If it is an extended signal timer, we need first to deactivate the input and then generate another signal to reactivate the timer. As we said early in the video, the TIA portal timers differ from those of the SIMATIC Step 7 mainly in data blocks property. Still, there could be some slight additional differences. So, we drag the timer from the toolbox, we fill in its parameters, then we move to simulation. We start by the timer's address we put for instance T0. When we come to assign the address for the timer, it must bear the letter T. As you know, each data types has its own space memory. We have put the link below for data types video. As we can see here, no data blocks added for this timer. We carry out with the rest of the timer's parameters. An additional parameter here is the reset. Even if the reset may be optional in some cases, with this example we need to reset the timer in order to reactivate it. Anyway, as rule of thumb, it depends on the program in which the timer is used. A critical point to consider is to make sure we conform to the requirement of the process when we enter the parameters, especially when risks of hazards are involved. That's why we need to pay special attention while simulating before to load to physical devices. For instance, if we mistakenly enter the wrong time scale, could result in the process not running, hence time waste. The same as the previous on delay. The timing starts by clicking on the input and the output turns on after the preset time is elapsed. However, as we can see here, the output here stays active even if we release the input. This is called a retentive timer. To turn off the output and reset the timer, we click on the reset. In a nutshell, the choice of the timer actually depends on the functioning of the process and the automation professional's ability to adapt the code to the timer available if necessary. Moreover, as beginners, the best technique to be familiar with timers is putting them in practical examples, as we are going to do in the upcoming videos. Thank you for watching. Hope it's been clear. Now if you like the video, be sure to subscribe to the channel and give us a like to support us for more videos. See you in another lesson.